Hello, everybody. How is everyone? My name is Dave Newson. I'm a software engineer here, and I want to talk to you about living with legacy systems. A lot of people don't want to talk about legacy systems because it basically means what you've made in the past is not very good, and you don't want to deal with all those problems. And everyone wants to talk about greenfields and Docker and APIs and fantastic things that we're getting to use in the future. But the fact of the matter is that legacy systems are what the company's built on. It's stuff that's gone to production and stuff that's rolling. So it's kind of the backbone and the moneymaker of the business. I do these things, just so you know some background of things that I deal with. I also do some of these things as well, but mostly I do this. Conveniently, that's what you're all here for. So what is legacy? Pretty much everything. Once it's gone to production, you can't take it back. It's once a user's got their hands on it, you can't take it away. If you have a feature that's out there and the user's actively making use of it, they want to keep using it. And even if you've got a bug that's out there and they're using it like a feature, you can't take the bug away. You have to find ways to deal with these problems. Everything that you release to production has an ongoing maintenance cost. Some of it's really low, some of it can end up being really high. It all depends on what kind of sustainable system you ship, whether it's truly something that can be nicely automated or it's something that's got a lot of manual processes involved. So this immediately leads into technical debt, which is probably 90% of what people think of when they talk about legacy. Is huge swathes of technical debt in systems. What is technical debt really? So for me, I always use the iceberg analogy that what most people see on the front of the site are features and bugs. And if you ever talk to a client and they have a pressing need or you're trying to do something in the market, it's either a feature or a bug. But with technical debt, that's the stuff that's underlying in the system. It's the other side of the iceberg that nobody ever gets to see. And that's improvements in infrastructure and new stuff that you add, and then it's actually dealing with that debt and changing things under the surface. So some examples of what you might get: just badly written code that is hard to deal with, not having tests, issues with cache systems, validation, security problems, lack of logs. There's all sorts of stuff that falls into this category, and you want to be able to easily deal with it and break it down into something that you can maintain and improve. At best, debt is an acceptable risk. The space shuttle, I don't know if you know, but there were huge periods in the launch sequence where if there's a critical failure of the launch vehicle, there was no survivable exit, and they were all acceptable risks that the astronauts took when they lifted off. But at worst, it's a landmine waiting to trip you up as you try to do something with the system and improve your life. So why do we end up with any of this debt? Like, where does it all come from? Well, the main one is usually got to go fast. Like, you want to get to market, you want to deploy something, you want to fix a bug, you want to do it as fast as possible. But it falls into this triangle of development where you can have fast, cheap, good, but you can only pick two. And the sacrifice when you want to go fast and do it with two developers is always the good. It's just get it done, get it out. There's also the aspect of just enough knowledge to be dangerous. This is any new technology. Everyone remembers, when MongoDB was fresh, no SQL, everyone was like, yeah, let's do this. And then they realized that, oh, it's not a replacement for a relational database. It's a different tool for a different job. New approach, not having enough research, failure to plan, all that kind of stuff. It's junior developers, it's new technologies, it's everything. So it can come from all sides. There's also the broken windows theory, which is, it's a criminology theory that talks about having a rundown neighborhood. And if you have one broken window, you're going to end up with more vandalism, which will lead to further crime as the neighborhood degrades. This translates to code as well. If you've got a legacy system and the code in a particular controller is terrible, everyone who goes in there is like, why bother improve it? There's nothing I can do here. I'll just I'll change that and I'll run away. And it just normalizes this poor quality, and it starts with that controller, and then it goes to another controller, and then it starts showing up in services, and it just gets worse and worse and worse. And it leads to the everything is terrible conundrum where everything you do is bad because this whole system is bad. So you can avoid debt. That's one of the best ways to deal with debt, is to completely avoid it. There are ways to avoid it. One is automated testing, because humans can't be trusted. We don't know what we're doing. We make the bugs. We're the source of the bugs. Why would you trust us? You've got to create an automation suite. You've got to get it green. You've got to keep it green. You've got to get the coverage high, and you can have multiple automated test systems. You don't have to stop at unit tests, or you don't have to stop at browser tests. You can layer these things over and over and over and over and over. You can even have like other teams in other regions testing your stuff for you, so they don't really know anything about what's going on. And that's basically like a third-party pen test as well. They know nothing about your system. They're just hitting it, trying to break it. So these are all possible options. And with keeping it green, Picard tip suggestion: if it was on red alert, then red alert means nothing. You can't have a red suite and go to production and leave it like that. Like, that's not a good way to run your life. So automated testing. You've got lots of options. You can do acceptance end-to-end testing. So you just run a user simulation, run a browser against it, and automate that process. That's a really great way to test it front to back. You've got functional testing, where you sort of avoid the browser and you talk to the APIs, or you mock parts of the system if you've got a front end. You've got integration testing, where you take your individual components and plug them together and make sure they actually do what they're supposed to do when they communicate in the code. And you've got unit testing, the smallest set of components that make sense, and just make sure that these things in isolation do what you think they're supposed to do. You've got linting, make sure your code looks nice, which is quite important. Static analysis, so you can have it examine the code for you, and based on that examination, you know if you're making stupid calls or you've got things back to front. And you've also got mutation testing, which is a new kid on the block, which if you've ever had a test that's green, but you've got a bug and you're like, but doesn't this test cover that thing? And so you've gone into the code and you've shot it in the kneecaps and expected the test to go red, and it doesn't. That's what mutation testing is supposed to find. It will tweak conditions in your code, and then hopefully you see your test fail. If it doesn't work that way, then your test isn't covering the stuff it should do, and you know your test is bad. So it's kind of testing the tests. Solid is a great way of avoiding tech debt. People, if you don't know Solid, it's like one of the things that you need to go and investigate as doing OOP in PHP. The simple breakdown for this of all of the parts: single responsibility, do one thing; open close principle, don't make me edit your code, just provide me a way to plug into it. Liskov, children should behave like their parents and not do weird things. Interface segregation, make small interfaces that represent actual purposes. And dependency inversion, deal with abstracts rather than interfaces. This is all basic stuff. I'm not here to talk about Solid. That's the short version. Peer review, another option. You do code review. Code review is always terrible. Nobody ever comes away from code review going, that was perfect. But I'm a staunch believer in these points of code is what's actually going on. Comments tells you what the intent is. Tests are your proof that it works. Your commits contain the reason why you did this. PRs are a summary and explanation that people can hopefully then use to understand the rest of it. And documentation tells you how you're supposed to use it as a whole. And I don't really agree with the self-documenting code concept. Maybe I'm just not writing very good code. I don't know. I am talking about legacy, so that could be a thing. But generally, I would say I prefer it this way around. There's all sorts of libraries that we use, Symfony itself being one of them, where you're trying to work out why it's doing the thing it's doing. And the Git history tells you absolutely nothing. And you're like, why did you add that crap? Well, I'm never going to know. I'll guess. Avoiding, great option, but also there is a reason to safely accumulate your debt. So why would you accumulate it? One option is just to be lazy. And that's a completely acceptable reason. Like, you are allowed to be lazy in your code. I was lazy just the other week. I made a nice, boring factory, which it sits on the edge of Symfony, it uses the container, it then creates a couple of storage classes, and it's kind of the pattern where you go, oh, you shouldn't be doing stuff with a container like that and filling dependencies. That's the kind of thing you do at the service level. Sure, but if I'd done it right, it would have looked a bit more like that, and then extra layers for the compiler pass, and then another layer for exceptions, and then the service definitions. No, avoid over-engineering. That's another reason why you might want to accumulate debt, as well as the lazy option. Screw that 5-class thing, I'm not doing that. Like, we don't need it. I explained in the pull request for that particular piece of work. It's unnecessary, we're not going to expand this system. It's there to solve a problem. Don't worry about it right now, we'll deal with it later. Some debt is healthy, which is an odd thing to say, but there is a thought that developers should accumulate as much debt as they can stand. And for the better developers in the room, that's not very much. You won't like let yourself take this on and accumulate things that make you uncomfortable. You'll usually do things the right way. And then when you get to the edge, you're like, maybe I'll just leave that for now. Gotta go fast. Always gotta go fast. There's no getting away from that one. Sometimes you just gotta get stuff out. And works for me. That's another common one. Like, you know, if what you've got is functional, then sure. I mean, there is this one guy, Peer to Levels, who remote OK.io, it's a single PHP file, and it generates in $2,000 a day with no frameworks and no libraries. I mean, sure, I can't really argue. He received a lot of crap on Twitter for that one, but sure, it's $2,000 you've got, why not? And external forces, you will accumulate debt from external forces. You've got other people you work with, there's business priorities that shift, there's, you know, systems that you thought were one way and now they're changed to be something else. As Picard once said, it's possible to commit known mistakes and still lose. Your code may be perfect, but then it will have some torpedo go into the side of it, which is a new business requirement. But what you can do is you can make debt safe. You don't have to leave these nightmares lying around. You can quarantine it. You can put it somewhere. You can say that I'm going to limit it to just that one factory. And then you can put it behind an API. Like, that factory's API is not going to change if I decide to deal with this debt. It still takes stuff in and puts stuff out. And the better you hide your evil deeds, the less you have to pay for later down the line when you actually come back to the debt. It's not hiding your evils that usually leaves to systems that can't be maintained. So when do you pay back your debt? So you're inevitably going to collect some debt over time, as I'm sure you all know. You actually have to dedicate time to debt. You have to enforce it to be tackled regularly. Because if you don't enforce it, no one will do it. Because it lives so far below the waterline in the iceberg. Other requirements, other things from clients who are like, but I've got a genuine bug. What are you doing? You're like, oh, I'm fixing something to do with the logger. And the client's like, I don't see any of that. And it's like, yeah, but it's kind of important. But you end up in a terrible cycle of busy teams make debt, busy teams can't deal with it, busy teams are slowed down by debt, and you go round and round and round and round until you can't move anymore. Another option is a TikTok approach, where you work from one side on doing features, and then you switch to doing debt, and you keep that pace. Another option, just stick it in the sprint. Another one is to track velocity and say that we're going to spend 20% of our time dealing with debt, and you just make sure that that 20% stays stable. If it becomes a lot of time dealing with debt, you know something's wrong. If it becomes not enough time dealing with debt, I mean, as much as I would hope that it's now a perfect system, chances are there's still loads of debt, and you actually need to get that 20% back. They're probably under pressure to deliver features, but it's not healthy to maintain that, because then you'll just end up with way more debt. So actually dealing with it. Dealing with debt, you could deny it. It's not a bug, it's a feature, it's fine. I don't know, it works the way we set it up. It's, you know, you're using it wrong. You can have anger about it. We just burn it. Just, no one want to deal with it. You know, we'll throw all this away and we'll do it again. Famously, Netscape did that. They went, our code's terrible. We'll just do it again. They fell 2 years behind the curve. Couldn't compete with IE. We're in Netscape now. Where's IE now, but still. Bargaining, if it works, it works. I mean, we'll just leave it, don't touch it, and it'll be okay. Depression, don't make me touch it, because I don't want to be responsible for this thing. Like, you know, if I touch it, then I'm on the Git history. People are going to blame me for it. Let's not do that. And finally, acceptance. Samuel Jackson's famous Jurassic Park quote, hold on to your butts. So simple debt. Simple debt's great. Simple debt's fine. You just add some tests, refactor some code. Small code's easier, and celebrate, and done. Okay, great. We'll go home. But we don't always have simple debt. Sometimes we have pretty extreme debt. And somehow it just keeps on going. I don't really, what are you supposed to do with that?
Pretty sure that's a feature, Dave.
So how bad can it get? What can we do to ourselves? No services. So everything happens in controllers. You just pull from repos and you play with objects and then you chuck them back into repos or flush the empty manager or whatever you're doing. No domains. No one has the understanding of where one line stops and one line starts, which means your controllers aren't just talking to what they own. They're talking to what's owned by the system way over there. They have absolutely no right to talk to. No standards. So all the approaches are all weird and different and the code does its own things. There's no tests. Which is just, you know, it's a WordPress website. And lots of users, so you can't piss anyone off. You genuinely have to keep the system going. You can't afford to go, oh, I'll just swap that out, and then hooray, it's a new one. And then people find, oh, but I can't save users anymore. That's a big problem, and you'll get into a lot of trouble. Burn it, just destroy it, just get rid of it. It's fine, but you know, we don't actually deal with it. But you know, we should probably, you know, we talked about this, so don't burn it. Burning it's probably a poor choice. Instead, let's make things better. Let's actually get in and do something worthwhile. One of my probably best recommendations is greenfield everything. Like, one of the biggest problems with dealing with debt is you go into a controller, you go into a service, you go into a repeat, whatever you're doing, and you look at it and you just go, oh God. There's nothing I can do with this. Like, it's a nightmare. The APIs don't make sense. None of it's logical. There's no way to wrap tests around it because it doesn't have DI. It's doing its own weird thing. So greenfield it, stick it somewhere else, make a new thing, and then replace what you used to have. You can do it on a granular level. It doesn't necessarily mean it has to be a whole new website or a whole new library, be a new class or a new function. You just make it clean, give it a few responsibilities, stick some tests around it, and keep it green. And even like people say, oh, but we don't have the test suite at all. It's like, well, fine. You don't have to test the entire application in one go. Just put a test. Just set something up and get it green now. You only have to cover that one thing. So practical techniques for debt. Let's actually talk about how to deal with some of this stuff. One of them is actually raising the visibility. So make sure people can tell that there is debt to deal with, because this is part of the iceberg, in that even when you talk to your product team, they'll be like, but everything's fine. It's, no, it isn't. It's on fire. You just don't know. So you can use Jira, Trello, spreadsheets, strongly worded emails, anything, just so long as they know there's something to deal with. Consolidate your debt into easy monthly repayments. It can take multiple passes. Some debt can't be done in one go. You can't necessarily refactor an entire controller, an entire service, you know, an entire configuration system. It takes a few goes, and one go might pave the way for another go. And as you go through the code and you follow the tentacles deeper and deeper into the recesses of the system, you find new stuff that you go, well, that's debt as well. And so you flag it, you comment it, and you say, this is a thing that needs to be dealt with, and you stick it in Trello or whatever. But smaller changes are fantastic. Big changes, big bang changes cause big bangs. Don't make big bang changes to legacy. Legacy code does stuff you don't know it does. Don't change it all at once. So, as I said, sometimes it's just a case of flagging what's going wrong. And in some cases, the @deprecated tag is a fantastic thing to say, stop doing this, we have alternatives. And so long as you provide an alternative, they're really useful. There's a few functions in Symfony that got deprecated, show no alternatives. And I'm just sat there going, well, what do you want me to do? I don't really understand. Or refactor tag. You can use a refactor tag to leave something behind and say, we've noticed this is wrong and we should come back and fix it. The point about at least having these tags and making them generic is you can find them again. You can trawl for the form security ones, or you can trawl for SQL injection if that's what you've got. You can go through the whole system. Test what you can. So if you've got a really bad system that has like absolutely no test whatsoever, minimum thing you can do to actually get it testable, even if the code is terrible, is you can stick a high-level browser test around the outside, and you can make sure that what behavior it had when you started is still the behavior it had at the end. The more complicated the system, the harder there is to do, but that test never loses value. Once you have that test, that proves that your system works. They're the best tests at the minimum level. Where you have new code, get the coverage, add the unit tests. Like, don't get yourself in the same situation. You want to have all this tested and verified. Acceptable risk. Assume you're going to break things. Have a fallback plan. Don't make it a DB restore. Code rollback's nice and easy. Make it that. Make all changes backwards compatible. Don't change behaviors. Don't break APIs. Do not break APIs. Like every change that has involved modifying an API, you add an optional variable, suddenly it doesn't do what it used to do. Someone was feeding that variable in when you didn't know they were because they were misusing the function. So much can happen with a broken API on legacy code. It's just crazy. So, some actual code examples, not necessarily stuff that's come from our system, but these are techniques I've used to get us out of problems. You might have an evil service, and we're calling this an evil service because it just returns arrays. And they could be multi-dimensional, several depth something arrays, and we've gone, well, we don't really want to continue to deal with this horrible array-based thing. We want to make it use objects. So the easy go-to there is we decide we're going to make this refactor. So now getTheme returns theme, getThemes returns an array of themes, and saveTheme will take an object. Brilliant. But we've made a couple of problems for our API because we've changed the types. These are no longer compatible with what they used to be, and we've completely eliminated one function and added something else. So if we deployed that, everything stops working, and your calls are all bad, and everything's terrible. Maybe we can just refactor the usages of this. We can just hunt them down and just change a few lines. But no, you can't do that. You can never do that. It's probably in the order of, at least 60 locations. And, you might have bizarro downstream code of that was manipulating the array, feeding it to an API, doing all sorts of horrible things you would never have expected. So greenfields it. Don't change it. Greenfields it. So instead of actually modifying it, make a different one. Put it in a different location. We're going to make a new theme service. It's going to be all the same tools. It's going to be all the same features. It's actually going to probably plug into the same database. But we're going to put it in a completely new location, call it a new service. So with this setup, we can take the old service and we can modify it so that we've got the new service injected into the old service. We can deprecate the old service, so anyone who comes across its usages know they need to migrate to the other thing. Like, the code's horrible, and you'll only do it on a case-by-case basis if you're actually refactoring the other thing, but at least it gives you somewhere to start, and people know they shouldn't be hooked onto this anymore. And why did I flag that? Oh yeah, we're still returning the same type. So we're not returning a theme object. We're using a theme object, and then we're turning it into an array. Array, it's the same interface, everybody's happy, everything works. The simple diagram version is you've got lots of things on one side that's using the code, you have your legacy theme service, you plug in a new service, and that's wrapped in tests. Yay, new code, legacy problem solved. One thing, if you were paying attention, you might have noticed with this, this class, is this little guy. That's kind of a mistake. I actually wrote this code, just like bashed it out last night as an example piece and went, that's not a good API. The reason for this is someone downstream of your new theme service can also use this toArray function. And they can write terrible, terrible array code that they're supposed to be weaned off of. The whole point of using objects is not to deal with these arrays. So this itself is kind of a mistake, not something that we actually want. So what you want to do is, as I said before, you want to quarantine your evils. You want to hide them away. So what we've done here is, instead of putting it on the actual theme object, we've made a private toArray function that lives with the legacy service. That means no one else can get at that functionality. It's nice and secure and safe. I mean, there may be situations where it makes sense for that toArray to be available, then you would stick it on a different normalizer class, but for the sake of this example, we want to hide it and prevent people using it. Evil arrays. So the other side of the same problem is that we have just objects with arrays, and you like looking at the code, you can only guess what's actually on this array. You would have to breakpoint it in every scenario to figure out what's being fed in, what's being fed out, what's going around, what's getting changed. And generally, this is just, you find it in code and you don't know what to do. It's, I can't do anything with this. It's like just anonymous data. So what can we do? Well, we can actually use the array access interface, which is a PHP thing. And we can turn an object into an array. So on the other side of this, if we did want our theme object to be accessible as an array, we could take our lovely theme object, we could bolt on this trait, and we could turn it into an array access. And then with the trait, because I'm not a heathen, like I want to be able to share this to other people so they can use the same functionality because it's generic, you can actually access the theme object as an array with the one very annoying caveat, which makes this a very specialist tool. If you have one of these little array type checks, it doesn't work because the object will not make it past that array type check. I'm annoyed at all sorts of different things about the PHP internals not supporting some kind of array workaround, but that's neither here nor there. Another great tool you can use for good releases is feature flags. So if you're refactoring something and you want to be able to get the code out and make sure that even with your changes, everything still works, you can use feature flags to control what pathways are being executed. This means that you can do your release and your code is not active, but your release was fine. It also lets you detach new feature releases from new code releases so that when you deploy something, clients don't go, I noticed you released this feature. It has subsequently broken absolutely everything. So this gives you a way to work around that problem. Evil feature flags are a thing though. If you have this kind of thing in your system, you will end up with it spreading like crazy just everywhere, and you'll have these checks for infinity. So the best feature flag is the kind of feature flag that you never actually see. You have factories and you have, they supply objects with generic interfaces, and then you never see the feature flag again. Evil conditions are a similar thing. Nobody wants these. Switch cases, if cases, all over the shop. You can work around these by turning them into objects and wrapping them nicely, and then you're just asking a question of the wrapper. You're not actually having the if statements dotted all over the place. You can also do more in that. You can create a factory that has various abstractions. So if you feed it a variety of objects, you can have them wrap it automatically by checking compatibility with the thing that it's making interaction to. I don't think I've really got time to talk about the evil attributes, even though this is the last piece.
I think you do.
Oh, okay.
People want to hear about the evil attributes? I think there's a lot, people want to know about the evil
attributes are the best ones. So you have an interface that you've made, and it supplies an ID and a title. Like that's the starting point for, say, like a dashboard widget. And then your implementation says that it's, yeah, I'm user thing, and I have this translation. Great. The problem with this is it scales with the number of attributes that you've got. If you have like 100 of these things, it gets pretty out of control. So a better interface is to have a configure function that actually takes an ID and a name into a completely different class. The good thing about that is you can have as many different functions on this builder as you want, and it can just add and add and add and add. The great thing about the builder implementation is it reduces your interface, for one thing, and it also insulates your implementation from your API. So when you feed this builder into the class that's using it, you might have something change in the implementation. I've even got it in my example, which was a complete accident, where I have the name function but it actually sets title on the definition because I call it something else because, you know, that's what I decided to do. The builder can grow and shrink and the function names can change, and as long as you backwards support your API, you're all good. Your under the hood implementation, that can be modified all the time. This just writes into a definition object with the title and the importer, and it's constructed by doing that code. It's a lovely piece of insulation that just, you have your object talk to the builder talks to the definition, and then you put your object onto the definition as well, and you've got a lovely configured thing with a nice backwards compatible API. The final piece of the puzzle with this is you can use the builder pattern and feature flags together to basically have it configure the builder with a feature flag, and you get all the benefits of all of the things. So final thoughts, test as much as you can, reduce the scope and quarantine your debt, figure out the surface area and plan your attack. Greenfields is always an option. Some debt's still healthy, and debt is a challenge to be conquered, but it can be fun if you attack it the right way. Do we have time for questions?
I think we've probably got a few questions in the audience. Let's have a look. Who's got a question? Hand up if you do. And I'll come running over with the magic microphone. Anybody? We got one over there, so.
Oh no.
This looks like it's going to be a tough question. Here we go. Hope you're ready, Dave. Here we go.
You're going to ask me something internal.
Hey, Dave, what's up? In your last example, the green, over there. So it feels like we are feeding the feature flags into the builder. Shouldn't the builder be aware of the feature flag internally? Shouldn't?
No. The reason is because the builder is part of whatever system you're building. It's got nothing to do with the rest of your technology. And to be fair, you could feed the builder, you know, the name of the feature. So you could say builder feature name, and then the builder internally could probably use that somewhere to figure out if the feature's on or off. But with the builder pattern, the other thing you can do is you're not restricted to just feeding it these names. You can actually run code and figure out a true or false answer. So you get a lot more power. You can give this thing dependencies, and it can go, sure, give me a sec, I'll just check my DB.
Yeah, plus it also, you look at your definition and you know what it's going to take in automatically, and you go like, oh, this feature is not being fed to this builder. So yeah, all right, cool. Thank you.
Hey, Saza, do you want to just say that into the mic, mate, just so everybody's got the benefit? I'll come down here.
He's just giving you some exercise.
Here we are. Hey, it's working well. Pre-pizza.
Thank you. So I was just saying that the issue is that if the builder is aware of the configuration, that means that it needs to be aware of the configuration manager as well, which means that you are injecting another dependency straight off the bat, which might not be a good idea.
Oh, one more.
Any other questions? Anyone? Get the mic there.
You talked about one of the big issues of code legacy is having no documentation, which I agree is a big one. How to deal with it, though?
So it was the implementation?
The code legacy, we have no documentation. When you have
no documentation. That is a tough one because it requires a lot of humans. If you don't know the features.
The people, basically, most of the time, usually the people who coded or did the BA, they're gone most of the time as well. So.
Yeah, that's a big problem. I mean, that's basically like giving you a website and going, you figure it out. Like, I don't know. It's new. It's got features. If you're lucky, yeah, there's documentation. If there's not documentation, you kind of have to give someone the job of going through and documenting it. But you don't necessarily have to give someone the job and say, now this is your problem. You can make it a team effort that whenever you go into a system, you write a bit of documentation for it. You'd be surprised what you can get done with just markdown files in the code, and you flag it a certain way, and then some day you pull them all out of the repo and go, here's a whole ton of documentation that the system now has, that it has these behaviors. And then maybe that can be rewritten by a single person into something that's actually fluent for humans and for the product team. And they go, oh, well, that's cool. Now I get it.
Nice one. Dave, can I just ask you to go to the last slide in your presentation there again, because I think you're the sort of guy who'll be quite happy to continue a conversation even after this evening.
Yep.
Oh, fantastic. So folks, definitely reach out to Dave. I want to just give him a big round of applause, actually, because that was an awesome talk. Thank you, mate. Really appreciate it. Good on
Thank you.